So we're looking at the same problem. The only difference is I changed the word left to right. So the original problem is a left Riemann sum, but I want to use the same problem to practice right Riemann sums. For this video, I'm not going to be drawing a picture to visualize it. I'm going to show you how to just calculate this math without having to draw a picture. So first things first, we know that we have a right Riemann sum. We know this is the definite integral that we are estimating, and we know that these are the intervals that we're looking at. So let's start with our first interval, which is 2 to 3. Circling that in my table so we can focus on it. We have the interval from 2 to 3. Now I know for right, left, and right, left, and midpoint Riemann sums, we're always dealing with the formula base times height. We're creating rectangles. So the base is determined between the distance between your x values. So the distance between 2 and 3 is 1. So that means my base for that first rectangle is 1. Now the height is what depends on the type of Riemann sum. Since we have a right Riemann sum here, the right endpoint, in this case 3, is going to determine the height of the rectangle. The height is going to be -2 because f of 3 is -2. So overall, this area of this first rectangle in a right Riemann sum is -2, which means it must be below the x-axis, right? Because it's negative. So let's look at the next one. We have our first area of -2, and we're moving on to the interval from 3 to 5, circling that in my table. We first have to find our base and then multiply by the height. The base is the distance between the x values. So 5 minus 3 is 2. You could also just think how far away is 3 from 5? It's 2 away. So the base is 2. And the height is determined, again, by the fact that this is a right Riemann sum by the right endpoint. So 5 is my right endpoint on this interval. F of 5 is -1. So it looks like this second rectangle is also having an area of -2. And I'm going to let you finish the last two in class.